This is the mission 56 organized by Space Analog Station at Marte. This mission is happening during November 13th to 23rd. And then today we will have the presentation of Eduardo Salazar from Mexico. And then he will be doing a presentation about a power station, right,
Yes,
Eduardo?
yes,
Okay.
exactly.
Okay, just a moment.
My full screen. Okay. Good soul, everyone. My name is Eduardo Salazar Perez. Today I will be presenting the power station. Currently, I'm a member of the mission 56 of Habitat Marte, and I'm the power station chief. Well, first of all, I want to present the index of context. We will be presenting parts of the internal design, what technologies we'll be using for this station. Additionally, we will be presenting the structure, profiles and duties, as well as training program, which will be included part of the management of this specific station. As well, we will be presenting the specific protocols that are to be applied in this kind of station, as well as finally, we will be presenting the spin-offs and the benefits that these stations can bring to an habitat in Mars or also for the life as well in Earth. Well, first of all, I want to present this presentation, but not before presenting one of the crews I'm taking part currently. Currently, I'm taking part of the mission 56, but also I have been able to take part in other missions. For example, mission 40, which was held during the end of May of the principles of June, and in the future, I will be able to take part in an analog mission in the Space Analog Habitat Lunares, which is in Piła, Poland, along with a crew of 6 people, which are from France, Poland, and Canada, including me, which I am from Mexico. Well, let's start with internal design of this station. One of the most important things to consider when designing a power station is that it needs to be connected to all stations, since every specific station and facility within a Martian habitat needs to be connected to energy, since most, if not all of their systems, needs electrical energy to work. For example, the engineering facility needs energy for communications, electrical procedures, manufacturing, designing, and many other of the experiments. Also, the sanitation center and the health facility need electrical power in order to function correctly. For example, health facility, in order to monitor the health of the astronauts, the equipment they are using, and also in order to keep clean the facilities and installations they got there. Also, we are considering that every station will be dependent of the power station. Additionally, I have considered not only the power station, but also the generator of energy. So I consider as a part of the power station, not only the station by itself, but also solar farms, the kilopower energy generation, which will be based on nuclear energy generation, as well as an additional aeolic park, despite the fact that it has not been considered into this diagram. I added it by myself because of the implications that wind energy will have within the planet. Well, how did I design this specific habitat? Well, I designed it with these two proposals. First of one, the proposal which consisted in creating a space habitat with a 3-floor habitable area. So, but this area needed to contain a dormitory, a kitchen, dining room, toilets, and vertical garden additional to the installation and facilities it had to cover. So taking into consideration that most of our basic installations when we arrive to Mars would be built from rockets and especially from the fairings, which in order to get to Mars, they will carry the payload. And after carrying these specific fairings, we will be dividing these facilities into 3 specific rooms before even starting to build additional buildings or rooms within Mars. Another consideration I made, it was the one that Professor Julio gave us, in which the diameter of the cylinder, the fairing, whatever we want to talk about, will be of 8 meters. Therefore, we will obtain an area of 50.26 square meters. So we have to optimize this space in order to build as much as we want or need, and also to sustain our life within this system. Well, basically, the internal design covers the floors. The first floor will be the work zone, or the space which will be occupied most of the day. This will include zones for monitoring of electricity and power generation, as well as one space for research and development, and an airlock in order for astronauts to go out in order to maintain other facilities, to keep clean our facilities, or in order to make some reparations if one of the specific habitats or specific generators needs maintenance. Well, these work zones will include a zone for power monitoring, communication, operations, and control, and also to keep contact within the electrical center, as well with the other centers such as engineering, main station, as well as Earth if necessary. A second space that is considered is a laboratory for research, development, and the maintenance of new devices. For example, in this space, uh, the astronauts will be able to print in 3D some of the tools they need for their jobs, as well as if they need to bring something from outside and work it inside this workshop, they will be able to. Finally, there will be an airlock in order for them to develop their own extravehicular operation, because if most of the work is taken account in the monitoring zone, there are things that cannot be repaired automatically. So it will be necessary to send robots, astronauts, or other things in order to go to the place where the problem is, do a troubleshooting, and solve the problem in order for all the stations to have electrical power in order to function correctly. For the second floor, it was considered as a multiple use zone, which will include zones for cooking, dining, agriculture, and gatherings or meetings. Uh, this zone was considered in order for astronauts to have balanced foods, also for planting their own foods. In fact, Professor Julio proposed that if there's a pandemic or something happens in Mars and the station keeps isolated, grounded by itself, it has to sustain itself automatically. So the considerations I made is that we had to develop new techniques for cooking and preparing meals in order to sustain and be more optimal with our resources. Also, one of the proposals is to apply vertical gardening to obtain food as sustainable and possible. And as well, this zone can be used for having gatherings, for having dining, as well as social reunions if the astronauts want to, in order to keep morale high. Finally, the third floor of these facilities will be the rest and exercise zone, which will include zones for dormitories, toilets, showers, exercise, and personal activities astronauts want to do. And I consider three primary aspects for this floor. The first one will be the use of isolated and insonorized dormitories in order to keep privacy, as well as give each astronaut a sense of their own personal space. They can, in this space, they can be free of doing whatever they want, listening the music they enjoy. They don't, if they don't want to be bothered, they can be within these places in order for be on their own. Additionally, in order to make exercise, we will be using some of the elements that are currently using in the International Space Station, or new exercise devices that can be brought from Earth or developed within Mars. Why would we using this special exercise device? We have to avoid mobility problems. We have to keep our astronauts moving constantly in order for them to be able to move more easily and more agile within these planets, as well that is possible to use these kind of devices in order to generate more energy or additional energy than the ones we are already generated within the solar part, our nuclear plant, as well as our wind part. Finally, we will have to use a special toilet showers that are designed for space needs and constraints. For example, the image you can see is one of the designs that NASA is proposing in order to make a toilet for Mars and lunar use. They will be testing these kind of toilets within the International Space Station very soon. In the second part, we will be talking about applied technologies. Well, uh, what do we need to produce energy? Well, currently in Mars, we will need to bring some resource in order to produce energy, but the natural energy sources we can find, there are three kind of specific sources. One is wind, the second is solar energy, hydrogen, and finally, we will need to use nuclear energy because it's considered that solar, wind, and hydrogen energy by themselves won't be enough in order to make our stations function currently. Therefore, a consideration that we will need a smaller nuclear plants that we have on Earth, which the first one will be based on nuclear fission, and the most advanced ones in the future could be based on nuclear fusion. Also, by the way, we will be using solar energy, which the main ones are based on photovoltaics or solar panels, as well as in the thermal generation of energy. We will be gathering the heat from the sun and we will be accumulating in order to convert them into electrical energy or keep it as heat in order to maintain at a room temperature within our centers and all centers of planet parts. Additionally, wind energy is considered by the use of turbines and hydrogen energy by reforming or electrolysis. This basically consists in obtaining hydrogen by water. I will be explaining a little bit about the technologies I am proposing to use within these facilities. First of all, solar energy. One of the proposals that are made are most commonly seen when talking about generation in Mars is the solar energy, but we will be using a solar panels array that shall be used in crewed missions in order to provide energy for life supporting systems in Mars. What is the consideration that they are also making that they prefer to have and produce higher voltages in order to minimize resistive losses and therefore losses in voltage in order to keep a constant voltage and keep our systems functioning correctly. Finally, some of the additional considerations that are made is that we receive a lower solar intensity because Mars is much further than the sun, that is Earth. Also, regolith is always floating and suspended around planet Mars. So we will be modifying the solar spectrum and we won't be able to receive as much solar light as we receive on Earth. That's why we have to take care of the dust we produce on Mars, as well as take considerations to clean our panels when it's necessary. Finally, one of the things that is very important is that dust will be deposited within the rays, and if dust is over the rays, blocking our sun, the contact between solar light and the panels, they will make it more inefficient and therefore producing less energy. That's why we need to clean constantly these kind of devices. A second kind of energy generation device can be produced by wind. This can be a tertiary power supply in a primary nuclear mission, but it also will help us to enhance the safety and reliability of our energy generation. Um, Taking into consideration the wind speed that Mars presents, for example, in summer, goes between 2 and 7 meters per second. inflows between 5 and 10 meters per second. And in the case of the Dusptor, the wind speeds go from 17 to 13 meters per second. These values were measured with the use of rovers. For example, um, let me remember, Curiosity, and some of the rovers they have sent to this planet, to Mars, have measured some of the wind velocities, but in certain regions of the planet. When we arrive, we have to consider in which region the habitat will be located in order to determine whether wind will be useful or not in order to produce energy. Additionally, we'll have to consider that generation of energy via turbines will require a higher and much bigger blades than we are already using on Earth, approximately 3 to 4 times much bigger than we are already using. In fact, in the lower image on my right side, you can see the comparison within a small house that could be used in Mars. The second one, which is surrounded by a blue rectangle, this is one of the rockets we will be using to get to Mars. And the extreme will be the height of a wind turbine that will be required in order to function in Mars correctly and provide enough energy in order to function correctly. That's why it isn't considered as a main source of energy, but a complementary one. A third option of energy, and the main taking into consideration many of the papers I have checked and many of the consideration many researchers have made in order to for the production of energy, is the nuclear energy obtained by fusion, sorry. How will be obtaining electrical energy by fission? Well, for using fuel, we will be using uranium 235 in approximately quantity of 93% and 7% of molybdenum. As I have said, we will be using fission in order to obtain nuclear energy. How will be this working? Well, first, a neutron will be released from the nucleus of the generator. After that, it will be producing a nuclear fission, which will produce a great amount of heat. This heat will be sent to the heat pipes that are made with silicon to free piston Stirling engines, which by the motions that they are making, they will be producing the nuclear electrical power. This is the principle in which the kilopower reactor is based. Additionally, the SP100 nuclear reactor, which was developed by General Electric and analyzed by the United States Army, the Air Force, and NASA in order for it to be used in Mars simulations as well as interplanetary works. They analyze it not only for energy generation, but also in order for propulsion, in order to get to the planets or other surfaces more rapidly. Finally, it is important to say that the power you can obtain from these kinds of generations can be scaled. And the least amount you can obtain is 1 kilowatt for the kilopower reactor. And taking in account the design of the spin 100, you could obtain hundreds of kilowatts. But in a real case for the kilopower generation, you could be able to obtain 20 or 30 kilowatts of electrical power with this kind of generator. Finally, I made a consideration of hydrogen energy, which can be obtained by using local water of soil in Mars in order to supply electrical power and crew member breathable oxygen. That's the application that NASA gives to this kind of energy. But how do we obtain electrical current or electrical energy by using this kind of generator? Well, in the image on the right, you can see the basic principle of generation of the hydrogen cell or a fuel cell. In this case, we will be using hydrogen and an oxidizing element that can be oxygen, that basically is oxygen. This will produce an electrical power through redox reduction. This will say that hydrogen will be losing one electron and therefore uh, they will be releasing electrons that will make flow through this fuel cell, and after that we will be able to obtain water as a produce, and also uh, oxygen and other kind of products. In fact, this kind of energy generation was one of the most popular and was very well received and used on the space shuttle during the flights between the 70s and the start of the 2010s. What are the applications? Well, this basically this technology doesn't produce very high voltages, but it can be used for lower voltage applications, which will be very useful for the working of the electronics within a Martian station. Also, one thing that we have to consider additionally is energy transmission, not only the generation of energy. With the generation, we have just covered one of the parts. We will need to have our generation station as well as have a transformer in order to uh, elevate our voltage to levels that will be useful in order to transmit them to the other centers, to other stations, as well to other parts in Mars if necessary. Basically, we will be sending our energy to transmission line, which are rated between voltages 765 kilovolts and 138 kilovolts. By the way, this kind of voltages can be sent directly to transmission customers. As well, if necessary, it can be transferred to other places and after that to substations in order to bring this voltage down to a more suitable voltage for local facilities. For example, a customer of a substation will be using a voltage between 26 kilovolts and 69 kilovolts. But on the most basic case, for example, your homes, your households will be using a voltage between 120 volts and 240 volts. In this case, my proposal is to use an universal voltage in order for every person that will habit in Mars will be able to use any kind of device, electrical or electronic, without the danger of getting damaged if you use another kind of voltage. In fact, some of the concerns we Latin Mexican people have when we travel to Europe or other countries is the voltage. For example, we Mexicans use 127 volts in order to connect our devices to the electrical energy. But if we travel to Europe or other parts of the world and they use 220 or 240 volts, we are concerned if our devices won't be damaged because of the voltage they generate at their output. Additionally, we are this is the consideration of a high voltage alternating current system in order to distribute electrical power. Uh, by the way, we can use many kinds of cables. For example, the most common ones that we use at households are made of copper or aluminum if they are made for transmission lines. But one of the developments that has been made and very useful in Mexico is the copper aluminum wire that is being currently being sold, and its proposal says that this material is much lighter by copper because of its core of aluminum, as well that it has the same efficiency of transmission than the same use of the copper. It's cheaper and the danger of being stolen is much lesser because it would not be made from pure copper but as a combination of materials. So my proposal is to use copper aluminum wire. Finally, it's important to keep a monitoring of the station. Why? Because we have to consider how it is working along the station. We have to consider how it is working, how our energy generation is working, if they need reparation, if you need troubleshooting. Also, it's important to keep a record of energy consumption of each station in order to determine which stations need more energy or which stations need to have less energy. As well, it will be important to determine the levels of energy consumption of each station in order to develop other devices that are much more efficient in energy consumption. Additionally, we will be considering the option of use the satellite technology in order to determine the state of the facilities and to take photographs of the conditions of nuclear reactors, the wind parks, and also the solar farming systems. And in order to finalize this analysis of the technologies that are to be used, I want to make to tell you a case study. In this case, this is the Colmena mission that will be the first Mexican mission to send robots to the moon. This is developed by the Laboratory of Space Instrumentation for my university. In fact, I'm currently taking part of this mission. We are expecting them to launch on the final days of the next year in 2021, in which we will be developing 9 small robots in order for them to be launched to the moon by a private contractor. And after that, they will be deployed into the moon. They will fall into random places. And after that, they will try to gather between each other. In fact, they will try to cluster themselves. And after that, they will make a mechanical and electrical interconnection, therefore making a much larger solar panel than the smaller solar panels they had. In fact, that's the objective of the mission. We will try to build bigger solar panels. So in the future, we won't have to send bigger solar panels, but we can make smaller solar panels and give them the capacity to gather themselves in order to build bigger ones. This mission was presented during the International Astronautical Congress by the chief of the laboratory, Gustavo Medina Tanco, and you can check it in the procedures of the last year's IAC. Well, let's talk now about the resources we will be generated or the ones we could be transported first. We will talk first about the resource that we will be generated in the site. Well, we will be able to generate wind turbines by using the regolith we have in Mars. In fact, I have checked our designs, I have checked other papers, and they say that we could generate turbines by 3D printing by using Mars soil. That's why we won't have to bring these kind of turbines to Mars. Additionally, we can produce our own food by developing sustainable and renewable ways to produce it. And this has been a case of study in many centers, especially Habitat Marte, which has developed aquaponics as well as gathering food from vegetables as well as fish. Finally, we could be using regolith as a material for additive manufacturing in order for us to build, to maintain, as well as to make other devices. And we will need to transport some resources for example, the solar panels. We will need to use new ones when we arrive, or also we could use the ones that we are carrying on our transportation system that will take us from planet Earth to planet Mars. Additionally, we will need to carry some nuclear reactors that will be used along with solar panels during the trip as well as during the settlements within the planet. Finally, I consider that additionally we will need to bring the instrumentation needed to sustain one of these plants in order to keep a monitoring, and we will need to bring them from Earth in order to use it within Mars. Let's go with the management part. Well, my organizational structure considers the use of 5 astronauts. This will be the power station ship, which will be keeping a contact with mission commander as well with the main station chief. After that, we will be 2 chief of officers, one that will be analyzing the use of renewable energies, and the second one that will be analyzing the use of non-renewable energies, to be specific, the use of nuclear energy. After that, we will be using 2 engineers in order to develop operation plans, safety plans, as well as designing or checking mistakes or errors that the station could have. Finally, in the lower position, we will have technicians and researchers who will be developing the station in order to repair parts that will be missing, developing new ways of energy, or doing additional tasks. I will be talking about that in the next section. And in the future, if the station grows bigger and bigger, and therefore we will be receiving more than 5 astronauts, these positions will be more specialized. After the chief officer, we will need to have additional positions. For example, security officers, power engineers that will be dedicated and devoted exclusively to the power generation, as well as operations engineers who main task will be more about operations, safety procedures, along with the security officers and the normal operation of the plant. Finally, we will have divided the role between technicians and researchers. Also, it's very important to consider that these positions will be rotating. A person won't be always in the same position, but for example, they can be technicians and researchers at the same time, as well as the engineers can be the chief officers or have multiple roles and positions during this stay on Mars. Well, let's go about the profiles. Well, in order to work in a power station, they will need to have the following studies. For a technician on the lowest positions, with associated studies or technical students, it will be enough for them in order to take part of this station. Also, by the way, it's desirable to have an engineering degree, for example, electrical, mechanical, mechatronics, energy, communication, and aerospace energy will be suitable for this kind of operation. As well, if they have graduate students, that will be much better. For example, if they have Master of Science, Master of Engineering, or as well as a philosophy doctorate or postdoctorate students, if it's possible they have. They will also need to undergo basic astronaut training as well as EVA training in order to develop the operations as the better as possible. As well, it's important for them to have a military or civilian background. So, regardless of the actual situation, they will be able to work here. And also, it's much desirable for them to have experience in electrical installations in order to maintain them working correctly or running as expected. Well, let's talk about our positions in a more specific way. What are the duties or responsibilities they will have? First of all, the power station chief, who will maintain a direct contact with the main station chief and also with the commander and with the chiefs of the other station we will have with planet Mars. This person will have to ensure the success of the center and correct operation. We have to coordinate mask, the management of the system, to make the most important decision, as well as a management of resources within this planet. As well, we have the chief officer, which will act as a substitute of the station chief in case a power station chief is developing another kind of work, is not possible, they will take the decision. The chief officer will be taking the role of the power station chief. Additionally, she or she will be specialized in the operation of a specific sectors. As I said, this person will be able to operate renewable or non-renewable resources. That's why I divided these positions into two. Additionally, this person will be responsible in the development of operation plans, as well as the design and establishments of new protocols that are to be followed within this power station center. Finally, the three other positions, which will be engineer, technician, and researcher. This research can be an invited one from other station or a researcher, which is part of the power station by itself. Let's go with the engineering position. This person will be responsible for the operation and procedures that are designed by the chief officer. This person will be the responsible of applying them within the power station. Secondly, this person will be responsible of defining and applying the security procedures that are to be used when in the power station, will have the direct contact and work with researchers and technicians in order to maintain this station running correctly and keep log of events in the station in order to have a report of accidents, procedures that were not well done, or procedures that had a better result than expected. Secondly, the technicians will be responsible of giving a maintenance and repairment of the equipment. As I said, if this equipment is not working correctly, it will need to be repaired by one of the technicians or engineers. Engineers will also need to have the capacity to take the roles of the technician. Well, the second work of the technician will be the constant supervision of the correct operation of the systems. This person will need to take time to control specific rovers or do a specific EVA tests in order to check the solar panels, the wind park, as well as the nuclear reactors are working correctly, and always have prepared the necessary equipment in order to undergo a repairing or maintenance operations. Finally, our researchers will be responsible for the development and study of new methods for energy generation, not only the ones we have in Earth or in Mars at this moment, but also will be developing new methods or studying the current ones in order to make them much more efficient. Additionally, we'll develop tests for new equipment, study this kind of equipment, test it, and finally conduct experiments that would be necessary within this center. The training program will consist in basic astronaut training, technical procedures, as well as medical procedures in order not to be using the medical center very constantly, and also in case of a pandemic and contingency within planet Mars, if they are isolated, they will be able to solve their own medical needs, but also with the capacity of having the assessment and the explanations from the medical officers that will be in Mars also. It's important to have also the analog training in order for them to study the next operations they will be developing, such as EVA training or the specific ones that require the specific work in Mars. Additionally, they will need to learn specialized topics of energy generation, distribution, and management, basically the topics for power energy that are taught at the universities who have electrical engineering as a major. As part of the astronaut training will be the use of some videos. In this playlist, I have gathered four very basic videos which undergo EVA astronaut operations as well as training in the use of nuclear energy and renewable energy. So these are more simulations. The engineer, the operator of the nuclear plant or the renewable plant energy generation can see how the work is developed and understand how they will be needed to use their work in order for them to maintain the work as correct as possible. Next, Google need to analyze what kind of resource Google needs for 1 week. Additional to the resources Google needing in order to run our station, the astronauts will need to eat and drink water. One of the considerations that was made was taken for the work from one of the Mexican books towards in the path towards the cosmic man, in which the author considers that the amount of food they need is approximately 1.5 kilograms for Mars, also a water consumption of 2.5 liters, and a limit of calories of 2,500 kilocalories. And taking into account a crew of 5 people and 7 days in a week, the consumption of water, food, and calories specific are the following. For food, they will need approximately 52.5 kilograms, approximately two-thirds of the weight of an average person in planet Earth, as well as 87.5 liters of water, therefore giving an approximate amount of 87,500 kilocalories per week by the whole power station. In this case, was an approximate by using some of the books. Finally, there are many guidelines that we energy power station have to provide to the other centers, since the power station will deliver energy to all the stations that will be dependent from the power station and will be placed in planet Mars. We the power station have to consider for them the following. We have to give them limits on power consumption based on the requirements and concerns we have of our solar panels, our wind generation energy, as well as our nuclear plant. We will need to give them some of the limits. As well, we have to give them additional sources of energy generation independent from the ones that are produced in the power station. We have to give them, for example, redundant systems in order, for example, for the medical center, they have to work despite the conditions that are in the power station. In case of, for example, a shutdown of the power station, the medical center cannot stop working. For example, the Mexican hospitals have their own electrical generation plant in order for them to keep working, even though in the city there's a complete shutdown of electrical energy. Also, we have to consider the use of efficient devices in order not to consume a great amounts of energy and power from the power station. And it's important to have constant communication with the other facilities in order for them their needs and the requirements of energy in order to deliver them more energy or to keep the amounts of energy they are currently using. As well, it's important to contact to have a special communication with the engineering center for the design and development of new devices the energy station will need in the future. Let's go with the part of protocols. We will need to consider two kinds of specific protocols. One for the specific case of energy, in which we will be considering generation, transportation, consumption, distribution, and monitoring. So this kind of procedures and protocols will be needed to run a power station plant. The second one, which will be more focused on the people, will need to consider daily tasks, the food generation, nominal and emergency operations. For example, how this station will work under normal conditions in case there's an emergency on the nuclear reactor, or also in one of the centers that is being destroyed or being having problems. Additionally, we will need specific protocols for research and development, extravehicular operation, as well as maintenance of this station. Let's go. What routines will need to be applied and used by the operators of this power station? We will need to consider daily tasks as well as food generation, nominal operations. In this case, we will be the routines for daily operations, as well for maintenance, research, development of these plants, specific routines for gatherings, meetings, and celebration, and scheduled routines that astronauts will follow during the stay in planet Mars. For the protocols of safety, as I said, I consider two specific possibilities and positions. One considers the normal operations of a plant, and the second one considers an emergency operation of this plant. In the normal operation, the following procedures have to be followed. First of all, is to maintain the instruments in a good state in order for them to function correctly. A continuous surveillance, so a person will need to be there, studying there, analyzing, or also automatic systems could be used in order to check the state of this facility. As well, it's important to have redundancy in the electronic systems, especially in aerospace devices, which are more capable to fail in a specific condition. We will need to have redundancy in order to keep our plant running, as well as thermal control in order for our station not to overheat and therefore produce more problems, as well as radiation protection for our nuclear generator and as well for the power station itself. Finally, for emergency, we have to consider the preparedness for an emergency. We have to keep our personnel prepared for an emergency situation, as well as having substitute power plants for every station in case the power station stops working correctly. As well, we will be needing to check the integrity of each part of the station continuously, as well as a containment structure for hazardous materials. For example, the nuclear materials will be bringing to planet Mars. After some time, they will not work anymore. So we have to have strategies in order for them to stop producing radioactive contamination. Finally, we have to consider medical procedure for electrical shocks or accidents that can have during the operation of the plant, and the movement of to save zones, or finally the evacuation of the plant. After that, we have protocols for specific occupancy and entertainment in order for astronauts to avoid boredom and psychological problems within them. We have to consider boredom or isolation generates a lot of psychological problems. In fact, it's possible to see and experience what are the considerations that we are currently having. For example, the isolation caused because of the COVID-19 pandemic situation. What would the astronauts do in order to avoid boredom and have entertainment or a good occupancy within the station? And they will have central areas where they can gather, have a specific formal or informal gatherings, reunions, speak between themselves. Also, we have to develop specific areas for them to practice physical exercise. In fact, during these pandemic times, especially for the people who are at home, who are isolated, one of the recommendations that my university gives to the students who are especially stressed with anxiety or with psychological problems, or even if they don't have, the recommendation is to practice some sport, either with machines or not. The recommendation is to practice some physical activities. As well, it's important for them to have the access to the technologies of telecommunications, such as radio, television, or internet. This will be very useful for them in order to have prior notice of what's happening and also have access to entertainment content, for example, news, TV, films, as well as music videos or things they want to learn and to have. As well, it's important for them to give them periods for themselves, not only periods where they have to be gathered. People need to have their own alone moment in which they will able to have some rest, reflection for themselves, as well as entertainment. It is important to also have some physical elements, some tangible elements for them to be entertained, such as games, films, books, or art. Even if they are able to produce their own drawings, their own art, it will be important to give them some elements such as paint, or other materials in order for them to create their own art. As well, it's important for them to have communication, not only with the crew members on the Mars station, but as well with Earth and their families if they have. So this will keep the morale high, and they will be motivated to do their work more correctly and well about problems that could be generated in a long stay isolated from planet Earth. Also, it is important for them to produce their own food. This is one of the proposals. Uh, it's important for them to use aquaponic systems. In fact, aquaponic systems are currently being studied by Habitat Marte. What will aquaponics will allow us to do? We will be able to produce our own foods. It will be fruits, vegetable, even fish. Also, it is important to use a vertical gardening in order to optimize the space and have a space for additional crops. As I mentioned earlier in the presentation, we have an approximately surface area of 50.64 square meters. So using all of the space for food production won't be as efficient than if we use it taking account the vertical space we will have in this space. What foods will be able to produce within the station? Well, by using aquaponics and vertical gardening, it's possible to produce vegetables, fruits, flowers that, believe it or not, They are eaten in Mexico. In fact, we eat pumpkin flowers as well as cempasúchil in some of our meals, as well that it is possible to produce fish for consumption. But this won't be enough. We have to consider additional sources of protein for the astronauts. So insects are also to be considered as a source of nutrients and protein for these astronauts. In fact, insects have been used in Mexico since pre-Hispanic times. So we Mexicans are very well suited to eat insects, prepare them, and use it for future missions. And additionally, yesterday I saw one of the posts by Agnieszka Elbertowska, one of the participants in Habitat Marte, and as well as analog astronaut in Poland. She told that they prepare meals with cockroaches that they have in their lunar habitat. So, despite some of the taboos that exist within the consumption of insects, we consider that they can be well suited for consumption in Mars and other planets. For 3D printing, we are considering the following. We will, we will need to use Martian regolith in order to produce some materials in order to build structures as well as habitats within planet Mars. In the right side, you can see one of the images of a new 3D printer that is being developed and tested in order to be used in the future with the regolith and produce new habitats for the space um, habitats within Mars or in the Moon. As well, we will need to use the current materials we are using within planet Earth, such as ABS, PLA, and PBA, in which we will need to use some of the different printing techniques such as using resin or using the classic additive manufacturing process in which we put layers of materials one layer over layer in order to produce one of our models. What products will be generating within planet Mars? We will be using 3D printing or additive manufacturing in order to you create compatible device for energy generation and monitoring. For example, these kind of solar panels have been designed in order to be 3D printed. They are not very efficient. They have efficiency of 20%, but they are also switchable for 3D printing, and could export this technology to other planets. As well, nuclear reactors are being currently studied in order for them to be printed 3D, as well as some of the tools or materials we will be needing to use in a power station in Mars. Let's go with the final part of the presentation. We will be talking about spin-offs. Well, what kind of technologies or applications from our power station will we need to use in planet Earth? Well, it's important to use new sources of energy. We have to implement new ways of producing energy more than the fossil materials such as oil or carbon. We have to make research, development, and implementation of sources of cleaner energy. Therefore, we have to reduce the carbon or oil-based energies and be able to use nuclear energy as well as wind and solar energy. And if possible, we have to take the applications of hydrogen energy in order to produce cleaner energies and therefore reducing the amount of carbon we are sending to the atmosphere. Secondly, as well as in planet Mars, in planet Earth, we have to clean and give maintenance to our solar panels, especially if they are in areas, for example, desert or areas where they can get extremely dirty. We have to maintain a good state for them in order to be able to generate more energy and generate them more efficiently. One of the proposals, in this case, was made by Malay Masumde, involves using electrical shocks to clean the panels. In this case, we'll send electrical shocks to the panels in order for them to be braked very safely and get rid of the dust they could have over them. Additionally, we have to develop new methods to clean them automatically as well as manually. But the most desirable ones will be that automatically in order to not to use to send people in Nevas in order to clean this kind of panels. Additionally, we are considering in this presentation the electrification of an isolated plant. But if we are able to energize an isolated plant, we have also to be able to light and electrify the isolated areas on Earth. In this case, that's why I consider a rural electrification. This photo is one of the rural communities in Mexico that is located in Oaxaca state in the southern states of Mexico. Currently, and historically, the state has presented one of the biggest indexes of isolation as well as social problems, lack of electricity, as well as problems that involves involve the lack of electricity. So electrification will allow to fulfill the electricity needs of rural towns, rural settlements, which will help to reduce inequality, social isolation, insecurity, and marginalization, which currently these towns suffer from the lack of resources after the lack of interest of the government. So we will need to consider this kind of electrification in the present as well as in the future. Additionally, the efficient use of electric power is very important as well in Mars, where we will have a limitation and constraints in energy generation, as well as in planet Earth, where we have to keep an eye in the energy we are consuming. For example, we have to conserve energy, for example, by changing our habits, turning off the devices, disconnecting the devices we are not currently using, because our devices, despite being turned off, while they are being connected, they are consuming energy in an idle state. Secondly, the energy efficiency. This will be a responsibility of the manufacturers of our products. More efficient printers, more efficient fridges, or more efficient devices, which will bring a saving of money of 7 cents of a dollar of kilowatt hour. This can be seen by us for a very low quantity of money. But if we translate it in the consumption of a neighborhood, a municipality, a state, a country, the saving of money will be much bigger, and therefore also the generation of efficiency, generation of electricity will be much more efficient and more suitable for the use on planet Earth. Another consideration I made is a standardization of electrical connection. Let's remember that I, as a Mexican, have a own device to connect my electronic appliances, as well as people in Brazil, people in Saudi Arabia, people in India, people in Europe, people in Africa have their own kind of connection. When we get to Mars, we have to standardize our connection. We cannot be using a different connections for the same appliances. Therefore, we have to standardize and specific electrical connection. That's why during the 80s and 90s, the International Electrotechnical Commission proposed a new kind of connection. In this case, it was a plug type N, and the current voltages, which we use 220 volts for voltage, 60 hertz of frequency, and a maximal current of 20 amperes. Currently, this kind of connection is being used in Brazil and South Africa. The big problem with the planet Earth that currently is being very difficult to change the habits of people. Also, it will be very expensive for us to change all our plugs and change it into an universal conversion, as well as all the energy facilities will be needed to change. But in planet Mars, it's possible to implement this kind of connection universally and widely used. And finally, I will take in account the impacts on the Sustainable Development Goals that were developed by the United Nations and consider the following. First of all, I consider the four objectives. In this case, what is a quality education, in we will need to learn about the preparation and training of astronauts, as well as research of methods for energy generation, which will help to improve education in rural as well as in city areas. Secondly, the affordable and clean energy. Um, I think this is very important, not only for Mars, but also on Earth. I have mentioned it very recently, in which we will need to learn about clean energy generation or cleaner. Let's take in account that energy has a cost on resources of planet Earth, as well that we have to take advantage of renewable sources of energy, as well as the nuclear energy. And it's important to say that the new reactors that are being currently developed are being developed in order to make our nuclear reactors safely by themselves. And if they have a problem, they will shut down and not produce the accidents or problems they have been producing to these years. Additionally, I consider a ninth objective, in this case, industry, innovation, and infrastructure constructions, which involve the construction of new power stations and new developments in energy infrastructure. This will be very important to generate new energy and new sources of energy, more efficient and also more reliable sources of energy. Finally, the three last one will be the sustainable cities and communities, taking into consideration the reduction of polluting elements of in the environment, such as smoke, dust, and other kinds of elements, as well as the promotion of the generation of sustainable energy. Uh, After that, I consider responsible consumption in our elements. When we arrive to Mars, we will be very reduced in the elements we have, but also in that we have to be very efficient in the products we are consuming. We have to also be very efficient in the energy consumption. Try not to use some specific elements that could be using more energy than the desired, as well as try to turn switches our devices. And also, it's very important to reduce the electronic waste. Try to use our devices as much time as possible and not only be acquiring the newest device every year because reasons of mode or any other reason. Finally, I took the 13th action, which is a climate action, and we will need to in order to apply this action, the use of cleaner energies. I have mentioned renewable energies, nuclear energies, and reduce our carbon footprint in order for us in planet Earth to have a better quality of life, to allow other people in planet Earth to have better quality of life, and use Mars as a source of growing for our civilization, but not as a source in order to abandon planet Earth. So these are my references, some of the articles I books I checked, as well as internet sites I checked in order to obtain the information I'm showing to you. And if you want to have a contact with me, these are all my social networks as email if you want to have a contact with me. Thank you very much for your attention.